Today we'll be discussing one of the most important principles in scientific measurement, significant figures. But why are significant figures even that important? Let's say, for example, you go to the store and you buy something for $3.75. You give the cashier a $5 bill and the cashier gave you back $1.20. How would you feel? What if they just gave you back $1? Or what if they gave you back nothing at all? This example shows us why significant figures are important. Each time you were shortchanged a little bit of money, you could feel that something was off. Each of those digits told us something important. Significant figures in scientific measurement tell us how precise a measurement is. That's why they're important to us. Today we'll be talking about the 6 rules of significant figures. 4 of them tell us which numbers are significant, and 2 of them tell us which numbers are not significant. Let's dive in. The first rule is that every non-zero number is significant. So let's look at this. Let's say we have number 1, 2, 5. So 125. Each of those numbers in this overall number, each of those digits, I should say, in that overall number are significant. They're all above 0. So we have 3 significant figures, or 3 sig figs for short. So anytime we see a digit 1 to 9, any of those numbers are significant. Let's do another example just to make it quick and drill home the point. Let's say we have 317 or 3,175. This time we have 4 significant figures because each of those digits are not 0. So that's 4 sig figs. Rule 2. Sandwiched zeros are significant. So anytime you have a 0 that's sandwiched in between 2 non-zero numbers, that digit of 0 is significant. So let's take another example. Let's say we have 402. Well, if we have 402, you have 2 non-zero digits, and then you have that 0 digit in the middle. That 0 digit, because it's sandwiched between 2 non-zero digits, that's going to be significant. So this overall number is going to have 3 significant figures. But now let's look at maybe a larger number. Let's say we have a crazy big number, 5,000,001. Well, you have 2 non-zero digits on the ends there, and then you have 5 zero digits in the center. Well, because those 5 zeros are sandwiched between 2 non-zero numbers, that's actually going to be, this number is going to have 7 significant figures because all 5 of those zeros are also significant. So this has 7 sig figs. Now let's look at rules 3 and 4. These kind of go hand in hand, so I group them together. So rule 3 is trailing zeros before a decimal point are significant. Rule 4 is trailing zeros in a number without a decimal point are not significant. So what do I mean by that? Sometimes what happens is we'll write a number like this, like 100, let's take 150, right? Well, if we just write it like this, you have these 2 non-zero digits in the front, and then you have that 0 digit on the end. Well, that 0 digit doesn't have a decimal point afterward. So this is telling us that these first 2 digits here are significant, but that 0 is not significant. So this number only has 2 significant figures. Whereas, if that number had a decimal point afterward, and I should clarify here, anytime we have a 0 that's following non-zero numbers, that's what we refer to as a trailing 0. So when we have a trailing 0 followed by a decimal point, just that little decimal point at the end, that makes this 0 significant. So in this case, even though it's the same number, this decimal point makes us have 3 significant figures instead of 2 significant figures. If we do another example real fast here, let's say we have 1,000. Okay. Well, if we have 1,000 without a decimal point, that's just one sig fig. But if we have 1,000 with a decimal point, that makes us have 4 significant figures, because these 3 zeros here are now significant because of the decimal point. I should clarify here too, the decimal point helps us see how precise a measurement is. So if you just have the 3 zeros after the 1 without the decimal point, we don't know if we're talking about 1,499. We don't know if we're talking about 1,009. The decimal point shows us, okay, this is 1,000 exactly to that last digit. Zeros that follow after a non-zero number and a decimal point are also significant. So this is rule number 5. So anytime you see a 0 that has the decimal point and then zeros after that, those are all significant. So let's look at an example here. Let's say we have the number 5.0. Well, the 5 is obviously significant. But the 0, this is the new rule that we're talking about here. The 0 is also going to be significant this time because it's following a non-zero number and it's after a decimal. So you have 2 sig figs. But let's say we have 210.000. Well, in this case, you have 2 non-zero numbers. Those are both significant. And this 0, this first 0, is previous to the decimal point, right? But then you have these 3 zeros following the decimal point. Well, because the zeros are following a non-zero number and there's also a decimal point included in this number, all of those zeros are significant. So instead of just having 2 significant figures from those non-zero numbers, we actually have 6 significant figures in this case. Rule 6. Leading zeros before the first non-zero digit are not significant. So let's think about this. Say, for example, I was writing down, normally we don't do this, but say I wrote down 051, and I was talking about the number 51. Well, that 0 is not significant. It doesn't tell us any important information, so this just has 2 sig figs. What this is really referring to more often than not is if you have 0.000, let's say 37. Well, even though these zeros are after a decimal point, there's no real information beforehand. So this is just, these zeros are just placeholders. All 4 of those zeros are placeholders. So the 3 and the 7 are the only 2 significant figures in this instance. And that may be a little bit confusing, but let's think about this. Another way to write the 0.00037 is also 3.7 times 10 to the negative 4. Well, if you see it written as this, it's a lot easier to understand. Oh, okay, the 3.7 is the only real information we're given from this number, or the only real significant figures that are telling us how precise this measurement is. The 3 zeros are just those placeholders in that instance. Let's do another one just for fun. Let's say, for example, I have 0.0507. Well, in this case, you have the 2 leading zeros that are just those placeholders. And then you have 2 non-zero numbers, so the 5 and the 7 are obviously significant. And because you have a 0 in between those 2, that 0 is still significant. So we have 3 sig figs. We went over a lot of information today, and really all of this can be summarized into 2 rules. All numbers are significant except in 2 instances. 1, zeros before a non-zero number are not significant. So anytime you have a 0 before any non-zero digit, that's going to be, those numbers aren't going to be significant. So that's just the previous example that we went over. Pretty much I'll write down a little example here, like if you have these zeros before, those aren't going to be significant, but the 7 still will be. And then zeros after a non-zero number without a decimal point are not significant. So in this case, I'm going to scroll down a little bit here. In this case, we're talking about the instance where it's 200 and there's no decimal point. There's only going to be one significant figure in this case. So one sig fig, whereas if you did 200 period, you're going to have 3 sig figs because those zeros are then significant. Hopefully this helped you in some way. If you like these videos, please make sure to subscribe and share with a friend, and I'll see you in the next video.